Alright, let's look at practice exam 3, problem number 4, part C. Alright, so limit as x approaches 1, and you can see that the first guy is, let's see, top is going to go to 1, and the denominator is going to go to 0, right? So 1 divided by 0, so this is going to approach, the first guy is going to approach infinity, right? And about second one is kind of the same. Top one stays at 1, and natural log of 1 is 0. So this guy approaches 0, which means that this guy is also approaching infinity, right? So you have an infinity minus infinity situation. So this is another indeterminate form. So we can apply L'Hopital's rule, right? So first thing we should do is just find the common denominator. So you have a limit as x approaches 1. Alright, then common denominator would be just a product of those two denominators. So quantity x minus 1 times natural log of x. Alright, so we multiply x by natural log of x. So you have a x natural log of x, right, minus, right, so you have x, so x plus 1, right, because of the negative sign, so we have that. Alright, then you can see that as x approaches 1, the denominator definitely approaches 0, because 1 minus 1, and here natural log of 1 is 0. Here's negative 1 plus 1, that's cancel out, so 0. So the numerator also approaches 0. Alright, so we can apply L'Hopital's rule now. So apply L'Hopital's rule. So limit as x approaches 1. Right, so derivative of the top, so product rule, derivative of the first is 1 times second natural log of x plus x times derivative of natural log of x is 1 over x. Right, derivative of negative x is negative 1, derivative of 1 is 0. Right, on the bottom, product rule again, derivative of x minus 1 is 1 times natural log of x plus first guy, so quantity x minus 1 times derivative of natural log of x, which is 1 over x. Alright, then let's simplify a little bit. So you have x over x cancel out, and you have a 1 minus 1 cancel out. So what's left is just natural log of x on top. Alright, then here you have natural log of x, and I'm going to actually distribute the 1 over x here. So I'm going to go ahead and write that out. So this is going to be simplified as limit as x approaches 1. And the numerator is natural log of x. And denominator is natural log of x plus x times 1 over x is 1. And then you have minus 1 over x, right? Then you see that x goes to 1, so natural log of 1 is 0, so this approaches 0. And this guy goes to 0, 1 minus 1 over 1 is 0. So again, the numerator approaches 0, right? So since we still have 0 over 0, we can apply L'Hopital rules again. So apply L'Hopital's rule. So you have a limit as x approaches 1. Derivative of natural log of x is 1 over x. And another derivative of natural log of s, 1 over x. Derivative of 1 is 0. Derivative of negative 1 over x is positive 1 over x squared. Alright? Then we can let the x goes to 1. Then you can see that here 1 over x goes to 1, 1 over x goes to 1, and 1 over x squared goes to 1 as well. So we have 1 over 1 plus 1, 2. Alright, that's it. I hope that this was clear.